Modern tech is designed to hide its secrets. We carry slabs of glass and metal with no screws, seams, or obvious way inside. When devices are sealed shut, they become impenetrable. This design choice encourages us to interact with our tools as passive users, assuming the hardware inside is a form of magic far beyond our reach. The Raspberry Pi exists to disrupt that passivity. It arrives without a case, intentionally exposing its internal logic. This overhead view shows a naked circuit board. It reveals a dense landscape of chips, ports, and exposed metal traces. While it looks intimidating at first, that exposure is an invitation to see exactly how a computer is organized. Understanding these naked components is the first step in moving from a consumer to a maker. It's the transition from simply using a product to understanding how to build one. The bridge between the computer and the physical world sits along this row of metal pins. These are the GPIO pins, general purpose input-output, and they act as the physical hands of the processor. By connecting a ribbon cable to a breadboard, you extend the computer's reach into an experimental workspace. The breadboard allows you to plug in wires and sensors without permanent soldering, turning electricity into a modular building material. Unlike the permanent microscopic circuits inside a smartphone, this setup is modular and visible. You can see every connection and change them as quickly as you can move a wire. This physical connection allows an individual to stop adapting to their technology and start modifying their environment to fit their own needs. Most makers start with the Blink. It's the most basic unit of hardware control, wiring an LED and a resistor to the Pi. The software side is just as transparent. The code is written in Python, using plain English logic that tells the computer exactly what to do with that specific light. The logic follows a simple cycle. The code tells the Pi to send power to a pin, wait for a second, and then cut the power. If the light stays dark, the project turns into a mystery. You have to investigate whether the LED is in backwards or if the code is looking for the wrong pin number. Learning to say, "It's supposed to not work yet," changes how you view mistakes. It removes the shame of failure and treats every error as useful data for the next attempt. When you finally correct the wiring and the LED begins to pulse, you have effectively commanded a computer to alter a physical object. You've moved from an observer to an operator. The next step is the mood lamp, which adds physical buttons to the circuit. These act as the ears of the Raspberry Pi. The logic shifts from a fixed loop to a responsive system. The computer now waits for a human to press a button before it decides what color to show. In the code, there is a blank space where the user must assign specific values to red, green, and blue light channels. This visualization shows the process of defining feelings through numbers. You decide which exact mixture of light represents a state of calm or focus for you. By defining these colors yourself, you turn the computer into a reflection of your own choices. It becomes a tool tailored to your internal state. Making moves towards utility with the breathing light, a device built to help with emotional regulation and self-care. It uses pulse width modulation, a technique that flickers the power so quickly that the LED appears to fade in waves rather than just switching on or off. The code follows a specific biological rhythm, like a 4-7-8 breathing pattern. The light brightens as you inhale and dims as you exhale. You've built an instrument to manage your nervous system, a sophisticated tool constructed from simple wires. This journey from a blinking LED to a regulation tool demonstrates the transition from learning a skill to solving a real-world problem. Beyond the hardware, the Raspberry Pi serves as a workshop for the mind. It provides a structured way to look at any obstacle. This loop, imagine, build, break, fix, is a blueprint for solving complex problems. It breaks a large, intimidating goal into manageable pieces. Practicing this cycle builds persistence. You learn that every problem has a cause, and every failure is a prompt to observe the system closely. This community of makers shows that confidence is built through hands-on experience. It's the quiet realization that you can pull a problem apart and understand it well enough to improve it. The result of these experiments is rarely just the gadget itself. The lasting change happens to the person at the workbench, who now knows they have the power to dismantle, rebuild, and create their world.